Assalamu alaikum kids. We have already discussed in previous videos how to add non-parallel vectors using head to tail rule. This time we will learn how to add parallel vectors. Vectors that are in the same or the opposite direction are known as parallel vectors. Addition of parallel vectors does not require any specific technique. Vectors in the same direction are added. So as shown in the diagram, you have a 30 Newton force and you have a 20 Newton force acting on the box, and both of them are towards the right. Because both the 30 and the 20 Newton forces are in the same direction, hence the resultant is going to be the sum. So 30 plus 20, that's 50 Newtons, and the resultant's direction, because both of them are pointed towards the right, both forces are in the east, or their direction is to the right or to the east, hence the direction of the resultant will also be east. On the other hand, vectors in the opposite direction are subtracted. For example, you have a 30 Newton force towards the right, you have a 20 Newton force towards the left, so the resultant is simply going to be 30 minus 20. They're in the opposite direction and hence you subtract them. So the resultant 30 minus 20 is 10 newtons, and the direction of the resultant will be in the direction of the larger force, which is 30 newtons acting towards the right. So hence 10 newtons will also be acting towards the right or the east. So let's take a couple of examples to show what we just learned. Let's say, for example, you have this box right here where you have a 40 Newton force acting towards the right. We have another 30 Newton force also acting towards the right. Because the two forces are acting in the same direction, the magnitudes are going to be added. So the resultant vector is going to be 30 plus the 40 Newton vector, which is going to be 70 newtons. So 70 newtons is going to be the magnitude of the resultant. Now, because these are vectors nonetheless, so you've added them, that's the magnitude. You still need to give the direction, and the direction will again be in the direction of the larger force. So that's going to be 40 newtons. That's just one way of remembering this. So this right here is going to be what? This right here is 70 newtons acting towards the right. So you can either say right or you can say east, or if you want to be very correct, all right, you can write the bearing, and this bearing is going to be bearing 090. All right, so that's the first example. So let's say, for example, you have this box right here where you have this 30 Newton force acting towards the right, and you have this 100 Newton force acting towards the left. Now, because the two forces are acting in the opposite direction, hence the resultant is going to be 100 minus the 30 Newton force, which will give you what? Which will give you 70 newtons. Now 70 newtons is again the resultant, that's the magnitude of the resultant vector. It's a vector, hence a direction is needed as well. So the direction of the resultant vector is what? Again, like we discussed, the direction of the resultant will be in the direction of the larger vector, which in this case is going to be 100 newtons. The larger vector is towards the left or in the west, so the direction of the 70 Newton vector will also be in the left direction. You could say it's towards the west, or you could say it's bearing 270. Either one is fine. So let's say, for example, you have this 30 Newton vector and you have another 30 Newton vector, both acting towards the right. And let's say, for example, you have this 50 Newton vector acting towards the left. So in this case, what you want to do is you want to add all the vectors in one direction. So over here towards the right, you have 30 plus 30. That's a total of 60 newtons. So a total of 60 Newton forces is acting towards the right, and 50 Newton force is acting towards the left. Now, because both the forces are acting in opposite directions, so the resultant is going to be 60 minus 50, which is going to be equals to 10 newtons, where of course the 60 Newton force is going to be the larger one, hence the resultant is going to be in the right direction. We can also say east, or we can say bearing 090. All right. That's the first example of multiple vectors in different or the same directions. Let's take a look at another example. So this time around, you have a 20 Newton force acting towards the left. You have a 50 Newton force acting towards the left. And you have a 40 Newton force acting towards the right. And this time around, the two forces acting to the left are 50 plus 20. So the total forces acting towards the left are 70 newtons. And the total force towards the right is just simply 40 newtons. Again, because the two vectors or the two combined vectors, so the combination of 50 and 20 and the 40 Newton vector, they are in the opposite direction, hence the resultant will be equals to 70 minus 40, which is 30 newtons. Now, the resultant vector's magnitude is 30 newtons, yes. But again, it's a vector, so we need a direction. And the direction will be in the direction of the larger vector or the larger combined vector, which is 70 newtons. And 70 newtons is towards the left. So the direction for R or resultant in our second example will be towards the left or the west or the bearing 270. Either one of these directions is fine. That's it for this video, kids. Inshallah, I'll see you in the next one. Bars out.